In this fourth item, we are asked to find two member forces in a truss, AB and CE. And anytime I see members lined up where I can possibly cut all the way through the structure, I think, and find or cut through the members of interest, I think method of sections. And sure enough, that's what we can do. Cut through there, cut away the support. And the beginning of the free body diagram, you got the applied load of 693. You've got 528 of the reaction already been provided to us. And so the members of interest are CE and AB. CB also shows up. I don't know if it's a compression or tension. I'm going to say compression. And so now at least I have a proper free body diagram. And let's see, I always like to use sum of moments when I am trying to find member forces with method of sections. And sure enough here, if we think about getting rid of the two unknowns by finding a place where they intersect, that happens to be joint C. And that is a location that I know its dimensions. It's in the center of the structure, so it is 10.5 feet over, right? It is 5 feet plus half of 11. Half of 11 is 5.5, so there's our 10.5 feet. We're given that it is 7.875 feet up from the base. It turned out that that particular value is not of importance to us, but we do have it. And I get some moments then for the equilibrium step. All right, I'm going to push this to the right so I can keep us all on the same page. Some moments about point C, let's take clockwise positive. We have AB times its, well, I guess that distance does matter. That's going to be 12 minus 7.875 feet, right? And then plus 693 times its moment arm over, that was 5.5 feet, right? Then minus 528 times moment arm of 10.5, all set equal to 0, right? So let's see what this works out. 12 minus the 7.85 is 4.125 feet. Okay, and then we have 528 times 10.5. Opposite of that is the 693 times 5.5. That's a positive number, 1732.5. Divide by the moment arm, 4.125. And we find out AB equals 420 pounds. And as shown here, it's in compression. And the positive number coming out of the equation told us that we assumed correctly, so therefore can interpret that straight up, right? For finding CE, I want to think about how I can get rid of as many things as possible. And if I go about point B, then I can get rid of the two member forces. Looks like I can, now let's take clockwise positive again. And note, I don't really want to resolve this into some difficult place. Let's take this up to an easy place, and that member passes this line of action through A, so that's where we'll take our sum of moments about CEY, CEX are the two components. That makes life a lot easier. And so when we do that, you'll see that we have a moment arm with respect to B of 11 times CEY, right? And then that'll be offset by the 528 going the other way, 528 times 5. That's all there is in that equation. And so CEY is going to be equal to 528 times 5 divided by 11. That equals 240. And that's just the component of Y, CE. And note that we've got this member, or actually this whole line, is to be 12 foot high, 16 foot run. Oh, that's a 3, 4, 5 triangle. Right? So if that's the case, then we've got 3 in the horizontal. And so we have 2 feet. We want CE at a 3, 4, 5 relationship. And that means that CE is equal to 5/3 of 240. Positive and as shown, and then therefore, and that means it's 400 pounds in tension.